Hello all and welcome to this AWS tutorial. In our tutorial today, I will provide a brief overview on AWS Wavelength and AWS Wavelength Zone. These are some reference URLs. I will have these URLs posted in the description of this video. I would recommend that you visit these URLs as they have additional information on this particular topic. So what is AWS Wavelength? AWS Wavelength is a type of AWS infrastructure that is designed to run workloads and applications that require ultra low latency or edge resiliency for 5G devices. Now, this is the simplest definition of AWS Wavelength that you can give to anyone, especially if you ask this as an interview question. There are a few keywords that you should always remember. First, that it is a type of AWS infrastructure. Second, it is designed to run workloads and applications that require ultra low latency or edge resiliency. And lastly, it is typically used for 5G devices. So applications or workloads that require ultra low latency or edge resiliency, particularly used by 5G devices, or in simple words like telecom providers or communication service providers or someone like that. It's essentially used for those purposes. Now, what is an AWS wavelength zone? Now, if you know what is an AWS local zone, a wavelength zone is very similar to your local zone. It is nothing else but an extension of your AWS region. And the difference between local zone and a wavelength zone is that although both of them are extensions of an AWS region, AWS wavelength zone is where you deploy your AWS wavelength infrastructure. So remember that AWS wavelength infrastructure is designed to provide that ultra low latency or edge resiliency, especially for applications that run on your 5G devices, for your communication service providers or your telecom services providers. So wavelength zones are particularly designed to run this wavelength infrastructure. That is where it is deployed. Now, how do you go about doing something like that? In order for you to deploy your AWS wavelength infrastructure, you need to create your one or more subnets in an AWS wavelength zone. And then you can run and manage various AWS services in that particular subnet. Now, AWS Wavelength deploys standard AWS compute and storage services to the edge of communication service providers. This is how it works. So you can have your AWS compute, your storage services deployed as part of your AWS Wavelength infrastructure. So again, you can create your EC2 instances, your EBS volumes, your VPC subnets, and most importantly, you can have your carrier gateways deployed or provisioned in your AWS wavelength zones. And we will look at this in the coming slides, wherein I have an architectural diagram that will help you understand how this communication happens. But hopefully, you now clearly understand what is an AWS wavelength zone versus what is AWS wavelength. AWS wavelength by itself is the infrastructure, and AWS wavelength zone is that logical extension of an AWS region where this wavelength infrastructure is deployed. Some concepts before we proceed further ahead. So the first concept that we have over here is the carrier gateway. Now, what is a carrier? Carrier is your telecom services provider or your communication services provider, right? You have a carrier. Like, for example, in US, you have Verizon or you have T-Mobile, AT&T. I'm sure in some other parts of the world, there are multiple other carriers. So what does this carrier gateway do? This carrier gateway serves two purposes. It allows inbound traffic from a carrier network. And secondly, it allows outbound traffic to the carrier network as well as the internet. So the inbound is only from the carrier network coming via the carrier gateway to the AWS wavelength zone, but the outbound goes to the carrier network as well as the internet. So hopefully that is clear. The next concept that we have over here is network border group. And I'm not going to get into the details. It is also called as NBG, but you can look and watch this particular video, that is AWS Local Zones Overview, wherein I have discussed NBG in details. Now the URL to this video is mentioned right here at the bottom. I will also have it mentioned in the description of this video. NBG works in a similar manner, just like how it works for local zones. In a similar manner, it works for wavelength zones as well. So refer to this video and you will get all your details. But NBG is very critical in a couple of ways. First, you can be asked questions around NBG, especially during your interview, as to how you can move the IP addresses around and how does it work, etc. So it's important for you to know how NBG works in general. Now let us look at how an AWS wavelength zone works. So you know that an AWS wavelength zone is an extension of an AWS region, and you need to create subnets in order to deploy your AWS wavelength infrastructure. So you have your region over here and you have your wavelength zone. Now in your regions, you could have multiple AZs, and AZs have their subnets. So the ideal way to leverage a wavelength zone with an AWS region is that you have most of your application deployed over here with your AZs and your regular subnets. But there will be certain portions of that application that require ultra low latency. Deploy those portions over here in your wavelength zone. So that way you can have the rest of the application within your AWS region, and those ultra low latency, let's say services, maybe it's an application tier, or maybe some functionalities that require that ultra low latency to be deployed in your wavelength zone. And then essentially you can have your communications gateway sitting right here. And we will look at another picture, an architectural diagram that will make things clear, but this is more of a conceptual diagram. So these devices via your CSP network can then communicate to your carrier gateway, and your carrier gateway can then communicate with your wavelength zone and with the application that is running over here on your wavelength infrastructure. So this is how it works end to end. Now this is an architectural diagram. This is an AWS region. You have two availability zones. This is your VPC. Now in this VPC, you have one subnet and you have second subnet in your AZs. So as I was mentioning to you earlier, right? You could have some parts of your application deployed in your regular AZs, but there will be portions of your application that require ultra low latency. Have those portions or those services, whether it's your application tier, whether it's a certain set of services that require ultra low latency, have them deployed over here in your wavelength zone. Now, how is the communication going to happen? So remember, these are your 5G devices. You have your tablets and your cell phones. These 5G devices are connected to your CSP network. This is your communication services provider network or your telecom services communication network. So they communicate with your CSP. This CSP in turn communicates with your carrier gateway. And via this carrier gateway, it essentially communicates with your wavelength zone. And then it communicates with the wavelength infrastructure, that is your EC2 instances. And in turn, it can now communicate with your application running on this EC2 instance. Now, as we saw earlier as well, right, from your wavelength zone, the communication to the outbound communication goes to via the carrier gateway, and via the carrier gateway it can go to your CSP network or it can go to your internet. So outbound goes to CSP as well as the internet, and via CSP it will eventually trickle down to these devices right here at the bottom. But the inbound communication, let's say from your 5G devices, it will first go to your CSP, and then via CSP, it will go to your carrier gateway. And then from your carrier gateway, it will eventually go to your wavelength zone, then to your wavelength infrastructure. And that EC2 is part of your wavelength infrastructure, and that application or the service is running on your EC2. So the inbound communication essentially can only come via your CSP network. Internet cannot directly communicate via the carrier gateway with your wavelength zone. It can only come via the CSP network. But the outbound can go either directly to the internet or to your CSP network. So hopefully this is clear. Now let us understand what is a carrier gateway. A carrier gateway provides connectivity between your wavelength zone and the carrier and the devices on the carrier network. So that's exactly what we saw over here. Let me see if I can erase this ink. So this is the bridge. This guy is the bridge. So these devices communicate with your CSP, and CSP communicates with carrier gateway, and carrier gateway communicates with your AWS Wavelength Zone, the subnet, the wavelength infrastructure, and eventually your application running on this EC2 over here. Carrier gateways are only available for VPCs that contain subnets in a wavelength zone. It supports IPv4 traffic. Now, we already looked at this, but I'm just going to repeat myself. It allows inbound communication or inbound traffic from your carrier network, and it allows outbound traffic to the carrier network and to the internet. No inbound connection or configuration from the internet can happen to a wavelength zone through the carrier gateway. So that essentially means that inbound is only via the CSP, and the outbound goes to the CSP, that is your communications service provider network, and it can go to the internet. But internet cannot have an inbound communication. This is not possible via the carrier gateway with the wavelength zone. This inbound communication from the internet, right? From the internet. So if you have your internet, this inbound communication via the carrier gateway to the wavelength zone, this is not possible. It's only outbound. So hopefully this is clear. The carrier gateway performs NAT, as in network address translation, of the wavelength instance's IP addresses to the carrier IP addresses. So if you come over here, you can see that this guy in the center, right? This guy is the bridge. The carrier gateway is the bridge. So the communication that happens, let's say you have your EC2s over here, and you have some instances or some machines running over here in your CSP network. So it essentially performs network address translation of IP addresses of the EC2 instances running in your wavelength zone or your wavelength on your wavelength infrastructure, and the IP addresses running for the instances running in your CSP network. So it essentially does the network address translation between the different instances and the IP addresses between your wavelength zone and your CSP network. So hopefully this is clear. So essentially this guy is right in the center, right? He's kind of a, as you can see, he's a gateway, he's a broker. So he's enabling communication between your wavelength zone and your CSP network. So hopefully this is clear. Now, this particular link has the list of available wavelength zones. In fact, I have it opened over here. And you can see that these are the different wavelength zones in each region. So you can scroll down and take a look at it. These are the different wavelength zones that are currently available. Of course, they keep on adding additional wavelength zones over a period of time. But I will have this URL posted in the description of this video as well. Go ahead and take a look at what are the different wavelength zones that are available. Use cases. So where would somebody want to use AWS Wavelength and AWS Wavelength Zone? So now you kind of understand that, hey, AWS Wavelength is used to deploy applications on an infrastructure, right? It's a type of infrastructure that require ultra low latency or edge resiliency, especially for 5G devices. So of course, anything that has high resolution video streaming, or anything that is an augmented or a virtual reality application. So if something like that is something that you are using, or you have a use case which might use, video streaming or high fidelity video audio or some AR VR applications, that's when you might want to consider using wavelength zones and wavelength infrastructure. The other use case is to run AI and ML driven video and image analytics at the edge to accelerate 5G applications, especially in medical diagnostics, sometimes even in retail or smart factory settings, but especially for medical diagnostics, because you really want those applications to perform any video or image analytics as soon as possible. And the third one over here is to develop any connected vehicle applications. So if you own a Beamer, you have something called as connected car or a connected car app. Now, any applications that require driver assistance or autonomous driving or in-vehicle entertainment, near real-time connectivity between the vehicle and the cloud could also be one of the good candidates or a good use case to use wavelength infrastructure and AWS wavelength zone to deploy that infrastructure. Now let us look at the pricing. So this particular URL has the latest and greatest pricing. So let us go there. So this is that particular URL. Now, if you come to this URL, you will see that there is no price that is mentioned over here. You can visit it and see there's nothing over here. There's no price that is mentioned here. But there is actually an option where you can request for a pricing code. And that is because there are not a lot of people who will typically use AWS Wavelength and AWS Wavelength zones. Also, it can become significantly expensive, right? Because if you're looking for ultra low latency and edge resiliency, in that case, it can become very, very expensive. So you can request for a pricing code, but a couple of things to keep in mind, right? Wavelength zones are available all across US, Canada, Europe, and Asia. If you remember earlier, we said that you can use your EC2 instances and other AWS resources in your wavelength zone as part of your wavelength infrastructure. But the prices of using those resources in a wavelength zone will be very different compared to their prices in their parent region. So that's where the difference lies. So you may say, yeah, it's standard, compute that I'm trying to use. Nothing crazy. But the price of using that very same compute on your wavelength infrastructure deployed in a wavelength zone is going to be very different compared to your regular parent region, your availability zone, your subnet over there. So that's one thing that you need to keep in mind, right? Because the pricing can get expensive. The second thing is that EC2 instances are only offered on demand in wavelength zones. And the third thing is that you can still use your instance savings plan with your wavelength zones. So if you are interested in this service, do kind of, try it out, play around with it. You can request the pricing. There are a lot of organizations that are currently developing 5G applications, mobile applications, something that requires near real-time connectivity, something that's related to AR, VR, or video streaming, or something like that, or especially if you're in healthcare with medical diagnostics, etc. Do explore this service. This service can be really very handy and can improve your application's performance significantly. So this is it from me today. I hope that this video was helpful. Do post your comments and I will see you shortly in some other video. Till then, take care. Bye-bye.